Hi, we are Chiara, Marta and Eleonora, three biomedical engineering students from Politecnico di Milano, and we are developing our project BRAINQUBE at NextLab. Our goal is to accelerate the analysis of fMRI data that leads to the recognition of resting state brain networks. BRAINQUBE focuses on a particular condition of the brain, the resting state, in which a subject is not performing any physical or mental task. It has been proven, in fact, that even during resting state, brain activity is not casual, but highly organized, forming specific networks that are responsible for the fundamental cognitive functions. To study the activity of the brain, we use the fMRI, an imaging technique which exploits the oxygen as the endogenous contrast mean, highlighting the areas with a more dynamic metabolism. In order to reconstruct the areas forming the resting state networks from the scans, we use a statistical algorithm, the independent component analysis, that performs a blind source separation on the signal and allows the reconstruction of statistical maps indicating the connectivity patterns. The practical implementation of the independent component analysis involves a first phase of images manipulation, where the scans are properly masked and the whole volume is divided into units, called voxels. Each voxel is characterized by an intensity value which is reported in a two-dimensional matrix, voxel per time, that is finally used to compute the independent component analysis. The statistical analysis of fMRI data is challenging in terms of execution time and energy consumption, since it involves a massive quantity of data. Each volume, in fact, is divided into 200,000 voxels approximately, and each experiment consists of hundreds of volumes acquired over time. Since the algorithm is highly parallel though, we propose an FPGA implementation of the independent component analysis algorithm to obtain better performances than software. Getting to a wider comprehension of brain networks is fundamental to fight the neurologic disorders that are directly linked to them, such as Alzheimer's, schizophrenia, and autism. Detecting brain networks through our implementation could be useful mainly in a clinical research context, where a time and energy-saving solution could help scientists to analyze greater quantities of data than usual with the same resources. Thank you for your attention. Feel free to write us if you have any questions, and be sure you don't miss any update following us on our Facebook, Twitter, and SlideShare pages. For more videos explaining our project, check the NextLab channel on YouTube.